So this one is a rate in, rate out problem. This is guaranteed to show up. There is one of these on every exam every year. So this is about fish entering a lake at a rate modeled by, now they give you the rate equation, and it is in fish per hour. So it is a rate, something per something else, fish per hour. So this is the rate of the fish entering, E of t. These fish leave the lake at a rate modeled by this function. So L of t is for leaving. I like how they say they're leaving, like they got caught, right? They got, anyway, like the fish can enter and leave the lake on their own. I don't know. It sounds like they have some kind of choice in the matter. Anyway, fish are entering, fish are leaving. They're both rates and they're both in fish per hour, right? And time is measured in hours since midnight. So time starts, time zero is at midnight. Right, so letter A, how many fish enter the lake over the 5-hour period from 0 to 5? All right, and then there's a second part to that, but let's stop there. How many fish enter the lake? Well, we're going to accumulate fish from time 0 to time 5. So it'll be 0 to 5, and it said enter the lake. So that's the E of t function. And you want to write E of t. You don't want to copy this whole thing. If you copy it wrong, it's going to be a copy error. Right? So just write E of t. And then, well, when you type it, you're going to have to type this whole mess. And they never give you nice functions. They always give you stuff that's like completely awful. So just make sure you're practicing the button pushing. All right, this is math 9 for our integral 0 to 5. And I'm going to type in this E of t function. 20 plus 15 sine. So we do need to be in radian mode. It's pi, now it says pi t. I'm going to type pi x over 6, close parenthesis, dx, and that will give us our answer. Oh, it says give your answer to the nearest whole number. So they want us to round to the nearest whole number of fish. So this would be 153 fish. All right, so not bad for part A. All right, letter B. What is the average number of fish that leave the lake per hour over the 5-hour period from 0 to midnight? All right, so this time we're doing the leaving function, and it says average. This is an average value. If I gave you a list of numbers and said, here, average these, you would add them all up and then divide by how much you have got. The integral adds it all up. We just need to divide by the length of the time interval, which was from 0 to 5. So it's going to be 1 over 5 minus 0, integral 0 to 5. And then this was average number of fish that leave. So we want the L of t function. And we're just going to type that in the calculator. So it's going to be 1/5. And then integral 0 to 5. And this time we want the L of t function. So that is this one right here. So 4 plus 2 to the power 0.1 x squared and dx. Now this is a rate of change. It's the average number of fish per hour. So we can decimal point this one. So 6, also they did not say round to the nearest whole number. So you need to do 3 decimal points. 6.059 fish per hour. So on average, that's the rate at which they are leaving on the interval 0 to 5. I'm gonna fold this over so you can read the next part of this. Part C, at what time from 0 to 8 is the greatest number of fish in the lake? Justify your answer. This is a candidate test, and the chart acts as your justification. So you don't really have to write a because statement. The chart acts as your justification. So hey guys, who are the candidates? And I'm not looking for a numeric answer here, but just like vocabulary words. How do you figure out who the candidates are that go on your chart for your candidates test? All right, good. Critical points are going to go on there. And what else? I might have gone through the chat really quickly. Scroll back up. So we do want critical points And good, critical points and endpoints. Perfect. All right. So when I go to set up this chart, and we're gonna plug in for time, and we want to end up with the amount of fish. We don't have an equation for that yet. We're gonna write an equation for fish. So just hold on, I'm gonna write fish real quick. Our endpoints are 0 and 8, and I left some space there. We need to get the critical points. Critical points is derivative equals 0. So what we're going to do is write an equation for the number of fish, do the derivative, and set it equal to 0. And someone had said zeros in the chat too. That was to me privately. I knew what you meant. It's zeros of your derivative. It's derivative equals 0 for critical. All right, so let's write an equation for the number of fish. All right, fish equals the integral from 0 to whenever. So I'm going to put just 0 to t of the number that enter, or the rate at which they enter, minus the rate at which they leave. Do you guys remember the party problem? I bring that all up all the time. People entering minus people leaving, we did that. It's the exact same thing, just instead of people, it's fish. All right, so fish is the accumulated amount of this integral, entering rate minus leaving rate. And we want to do derivative equals 0 to get our critical point. So if we do, fish prime, I guess I could have just called that F for fish, whatever, it's funnier that way. Fish prime, derivative of an integral, they're going to cancel out, and you're just going to have E of t minus L of t. So that derivative of an integral cancels out. You just have the entering rate minus the leaving rate. We're going to set that equal to 0 to get our critical points. And so we're going to add over L of t. And so you're setting these rates equal, which makes sense. Wherever the entering rate equals the leaving rate, that's where you're going to have, those two functions are going to intersect. And that's about really what we're going to do here in the calculator. So we're going to go to y equals, we're going to put the entering rate into y1, the leaving rate into y2. We're going to calculate where they intersect. The entering rate was 20 plus 15 sine of pi x over 6. And that was it. So that was the entering rate. That goes in y1. And then y2 is the leaving rate. So 4 plus 2 to the power of 0.1 x squared. So I put one of them into y1, one of them into y2. Again, they're not going to give you nice functions. They're going to be yuckies. You have to practice typing these. Like, you're going to look at it and be like, that's the function you gave me? Yeah, it's going to be nasty. All right, so I'm going to go to window. Oh, my window is very strange here. Our window was 0 to 8. That's what they gave us. It said from times 0 to 8. I'm going to make this be standard just to start out with, -10 to 10. I'm actually not 100% sure what that's going to need to be, but I'm going to start out with -10 to 10, and we'll just see what happens here. So I'm going to hit graph. We'll see if we can see these here, or if I'm going to need to widen out the window. Okay, yeah, I am going to need to widen out the window. I can see one graph kind of came down here and the other one's up here. They're going to intersect like somewhere there. So I need to raise the ceiling on this. So we're going to go to window. What do you want to make the Y maximum, guys? I don't know. I don't have specific directions on this. You kind of just need to fiddle with it until you can see what you need to be able to see. So what do you guys want to make it? You kind of just need to make a decision and go with it. 20? We'll see if that's enough. If it's not enough, we'll change it to 30 or 40 or 50. We'll make it something else. All right, I'm actually going to widen it out a little bit more. You can sort of see it there. Let me make it 40. We'll make it 50. That should be good enough. Again, you kind of just have to mess with it until you're good. All right, so this is the intersection that we want. Weirdly, that kind of looks like a fish. That's interesting. All right, so we're going to calculate this intersection. Second choice, intersect. First curve, second curve, just hit enter for both of those. For yes, you can kind of just hit enter for that too, because there's only one intersection, but I'll just move it over close to the place where they meet. Hit enter, and there is your intersection, 6.203. You can round. I think it's easier to truncate. Just take the first 3 decimal points. 6.203, that's our critical point that's going to go right here. Now, sometimes there's more than one, and in which case you'd have more values on your table. So, just, take all of them. In this case, there's only one. Now you have to copy and paste that value. So the way that you store that is quit out of there, go back to the home screen, hit X enter will bring it back, X enter, and then store alpha A enter. So X enter, store alpha A enter. It was cool. Couldn't we just use X for this? Yeah, in this case, that would work because there's only one critical point, but say there was more than one, you'd have to store one of them as A and one of them as B, you know, so just get in the habit of storing it. It'll work every time, right? X enter brings it back, store alpha A enter. Now we want to plug in here to get the number of fish. So that's this original equation, fish equals this. Now, if you plug in 0, integral from 0 to 0 is going to be 0. So, you know, we're starting out with nothing there. And now we're going to plug in this 6.203. So it's going to be integral, math 9, from 0 until alpha A. I put the value, and it's the entering function minus the leaving function. And remember, both of the functions are pretty nasty. So, you know, you got to be careful with your typing. So here's E of t, 20 plus 15 sine of pi x over 6. All right, so that's the entering function, minus parenthesis, because I want to subtract the entire leaving function. So I want to put parentheses around it. So minus parenthesis, and now I'm going to type this one. 4 plus 2 to the power of 0.1 x squared, close parenthesis. So I subtracted the whole thing, dx. Boom, this will give us the number of fish, right? 135.014. Oh, sorry. I don't have much space to show you guys stuff. I put that on my chart, and now I want to plug in 8. Now you don't have to type the whole thing all over again. Just go up here and bring it back. And I'm going to change the alpha A, let's copy and paste this value here, to an 8. So I'm just changing the A to an 8, hit enter, and it will give us that result, 80.919. And you have to go through all of that because, again, the chart is your justification. You're justifying this by showing every single candidate. All right, now they asked, sometimes they ask for maximum, sometimes they ask for minimum. Let me see what they said. At what time is the greatest number of fish in the lake? So maximum is 135 fish at time equals 6.203 hours. All right, so that was part C. Let me fold the paper over and we'll do part D. Part D, is the rate of change of the number of fish in the lake increasing or decreasing at 5 a.m., which is time 5 hours? Explain your reasoning. All right, I'm gonna pull out my favorite sticky note here. They're asking, is the rate of change increasing or decreasing? The rate is the derivative. That's what they gave you. They gave you rate functions. So is the rate increasing or decreasing at time 5? Well, the rate is increasing if the second derivative is positive, decreasing if the second derivative is negative. So we have these derivative functions, E of t and L of t. We're going to do the derivatives of those. Positive means increasing, negative means decreasing. So we're going to do E prime of 5 minus L prime of 5. See what that comes out to. And again, I'm plugging in 5 because they said at time 5 here. Positive means the rate is increasing. Negative means the rate is decreasing. Now, we use math 9 a lot on here for the integral. This time we're going to do math 8 for the derivative. And so the way it's set up is you're going to do d dx and then put the function right there and then such that, and it'll be x equals 5 for this. Right, so d dx function for entering 20 plus, oh, whoops. 20 plus 15 sine, here one more time, I gotta type all this in, pi x over 6, such that time 5, all right? So that is the first one. That's this E prime of 5. Minus, I'm gonna do it subtraction, and then we're gonna do it again, another math 8. So another math 8 d dx, and this time I'm going to type in the leaving function, which is 4 plus 2 to the power of 0.1 x squared, and then again, such that x equals 5. So we did a math 8 for this one, minus another math 8 for that one. Moment of truth, let's see what it comes out to. Negative 10.722. And then you have to write a sentence. The question was, is the rate of change in the number of fish increasing or decreasing at that time? So the rate is decreasing at t equals 5 hours because E prime of 5 minus L prime of 5 is negative.